Hi everyone, welcome back to the solutions for the homework 1, solving, graphing, and analyzing quadratic functions, where we're talking about how to factor, how to use the quadratic formula, how to complete the square, and then some basics about finding the zeros, axes of symmetry, the vertex coordinate, etc. So let's get started with factoring. Everything we do on this page is going to be based off of this function x squared plus 4x minus 5. We're doing this with one function so that we can compare all of our results and see that many times we're just doing different techniques to find the same, that will give us the same results. So, to factor, we did this a little bit up above, and we've done this since the beginning of the year. You've seen this from Algebra 2 and maybe even Algebra 1 and beyond. When I ask you to factor, set the function equal to 0. So in this is in function form right here, f of x. Whenever something's in f of x, it's in function form. Whenever something is set equal to 0, it's an equation, and we can solve it. I can't solve a function, but I can solve an equation when I want to know what it equals. So I'm doing product sum here because the a term is 1. And then I'm going to solve for x by setting each of the factors equal to 0. So I'm looking for two numbers that will multiply to negative 5 and sum to 4. Those numbers are positive 5 and negative 1. When I set those factors equal to 0, I get that the solutions, or the roots, or the zeros, or the intercepts, whatever you want to call them, x equals 1 and x equals negative 5. The way that I'm going to write this is x. Let me get a little bit more room here. The way I'm going to write this, if x equals 1 and x equals negative 5, I'm going to write x equals, and my answer is going to be in set builder notation from least to greatest. Okay, now if I want to use the quadratic formula, since I'm working with the same equation, I better get the same results. Remembering that a, this is a matter of substitution, b and c, I'm plugging in the values for a, which in this case is 1, b, which is 4, and c, which is negative 5. So x equals negative b, so that's negative 4, plus or minus the square root of 4 squared minus 4 times 1 times negative 5. And that's all over 2 times 1. So x is equal to negative 4 plus or minus the square root of 16 plus 20 divided by 2. That looks like x is equal to negative 4 plus or minus the square root of 36 over 2. So x is equal to negative 4 plus 6 over 2, and x is equal to negative 4 minus 6 over 2. What I'm looking at here is x is equal to 2 over 2, and x is equal to negative 10 over 2. What I end up with is, x is equal to negative 5 and positive 1. So that should be in set builder notation as well. Okay, lastly, this technique of completing the square. I know you've seen it, but it may have been a while. The first thing we do is write the equation as x squared plus 4x. I move the c term over, equals 5. I do that so that I can remember that I have to add 1/2 b squared to both sides. So I'm going to take half of b and square it, and that is 1/2 of the b term, and then I square that. So half of 4 is 2, and square that, and I get 4. So I'm going to add that 1/2 b squared to both sides. The reason that I do that, well, what I do to one side I have to do to the other, but the reason that I do that is so that on the left-hand side I end up with a perfect square trinomial, which means trinomial, 3 pieces. Perfect square, meaning that I can take the square root of that. X plus 2 squared will multiply out to x squared plus 4x plus 4, and that equals 9. The whole reason here is that I can take the square root of both sides. Oops, x plus 2, let me delete that. Erase that little part. X plus 2 quantity squared and 9, I can take the square root of both sides, and I get x plus 2 is equal to plus or minus 3. Now the plus or minus 3 is really important because I want to have two answers. Why? because this function is squared, which means it is going to have two roots. So x is equal to negative 2 plus 3, and x is equal to negative 2 minus 3. Guess what our answers are? X is going to be equal to negative 5 and 1. 3 techniques for solving a quadratic function. What I've done, what have I done? What does all this mean? When I find the solutions so when I say solving, I'm asking you to find the x-intercepts, right? Set the function equal to 0 and find out what x values make it equal 0. I know now, no matter what this parabola looks like, that if I go to 1, 2, 3, 4, 5, minus 5, and 1 are where that function crosses the x-axis. Now we start to talk a little bit more about some other things. I know that this function is going to be concave up. It's going to open up because a is greater than 1. The axis of symmetry. Well, that's found where x equals negative b over 2a. That should look familiar. That comes from this part of the quadratic function right there. That's the axis of symmetry. That's going to be this line that cuts the parabola in half. Let's do the algebra to figure out where that is. Negative b, that's negative 4 over 2 times 1. That looks like negative 2. So the axis of symmetry is a vertical line where x equals negative 2. Sure enough, that matches up with this pink dotted line on my picture. Now, the second part of this is the discriminant, this part in green, which is going to describe the roots. So it's more of a qualitative than quantitative description of what the roots will be doing. The discriminant is this part, b squared minus 4ac, and it tells you how many and the nature of the roots. So it qualifies them, it describes them. And again, I'm substituting 4 squared minus 4 times 1 times negative 5. Now, we already found this to be 16 plus 20. We already found this to be 36. What that 36 means is because it's positive, because I have a positive under the radical sign, I will have two real solutions. Real just meaning that this parabola will actually cross the x-axis. So by real, I mean that it crosses the x-axis. They're real numbers. Negative 5 and 1 are real numbers. Okay, now the coordinate for the vertex. I want to find f of negative b over 2a. I want to take that coordinate for the axis of symmetry. So I find the axis of symmetry. It's where x equals negative 2. That means I'm going to plug negative 2 into the function. And when I do that, I get 2 squared plus 4 times 2 minus 5. I get 4 plus 8. That's 13 minus 5. 13 minus 5. Oh, sorry. That's 12 minus 5. That is 7. So the coordinate for the vertex is, sorry, I just had a blank, is negative 2. It should be, is my math right here? 4 plus 8, 12 minus 5, 7. It should be negative 2. And, oops, I made a mistake. Negative 2 squared is in fact 4, but 4 times negative 2, there we go, is negative 8. This is where my hesitation came in. There was something that just didn't fit. Okay, so that's 4, and then minus 8 minus 5. So 4 minus 13 is negative 9. Okay, now it's at negative 2, negative 9. That makes a little bit more sense. Negative 2, negative 9. 1, 2, 3, 4, 9. Here's what my parabola looks like. Opens up. There's the vertex at negative 2, negative 9. The vertex is a minimum because the parabola opens up. And the y-intercept is, well, right here. I could look at my graph, but also I can make sure that, oops, I didn't graph this very accurately. Should have been through that point right there. So if I erase my line and redraw it, what I end up with is a parabola with roots at 1 and negative 5 that goes through that y-intercept of negative 5. So that's that yellow point. Hard, maybe a little bit hard to see, but that's it right there. And the y-intercept is at 0, comma, negative 5. Okay, lastly, save the easiest part for last. The domain of this function is all real numbers, and the range is going to be from its lowest point or its highest point if it opens down. But in this case, its lowest point, the range is going to be all y values that are greater than or equal to negative 9. Okay, and of course, just down at the bottom, I just want you to put your name. And that's that. Okay, I will see you in the next video.